right, so the next lecture is a continuation of image segmentation, and we have already studied like a couple of algorithms which can be used for image segmentation. And today we are going to talk about clustering. And clustering is like it's a well-known algorithm in machine learning area, but today we will see like how that clustering algorithm can be used specifically to solve this image segmentation task. Okay, so basically we will talk about two different algorithms. The first one is k-means clustering. The second one is mean shift. And for k-means, I think the algorithm which is used for this image segmentation, that's called SLIC. The full form, I think, is simple linear iterative clustering. And you will see like it's really very simple algorithm. And then we'll talk about like what are the limitations and how mean shift can be useful in some of the scenarios. All right, so before going to the segmentation part, let's first try to understand like the motivation behind clustering, why exactly we need to do clustering. Clustering, it's like a very general approach. The idea is if you have like some samples or some data points, what you want to do is you want to organize those data points into different groups. Okay, and that organization is termed as clustering. Now, the goal is when you organize those data points into those clusters, you have two different objectives. And these two objectives could be like your loss terms, which you try to minimize when you perform clustering. Okay, so the first objective is you want like very high intra-class similarity. Now, what do we mean by intra-class similarity? If two different samples are actually belonging to the same cluster, it means that they should be very similar to each other. All right. So if you have to compute like some kind of number to say that what's your intra-class similarity, then it will be something like you will try to find out pairwise similarity of all the samples which are there in the cluster. Okay. And when you try to average that, that similarity measure should be pretty high. If it's high, then it means like your clustering algorithm is pretty good. Okay, so that's the first objective. The second objective is when you try to compute the same kind of similarity between samples which are across different classes or across different clusters, you should get very low score, which means that if samples are not similar to each other, they should belong to two different clusters. All right, so they're kind of related to each other, but two different objectives altogether. Okay, so we'll try to optimize these two when we talk about these clustering algorithms. Now, another interesting aspect is clustering is it's like from unsupervised algorithms category, right? And in this algorithm, we don't need any labels. For example, like some of the tasks which we have been studying, for example, classification, object detection, you have seen that, okay, to be able to do classification, whether it's classical approach, for example, SVM, or it's like a deep learning approach where you're training a CNN, you do need some kind of class labels on those images, right? And you use those labels to actually compute your loss function and then train your model. Now, in case of clustering, you don't need any labels. So it's completely unsupervised. All right. And even if you think about like these two objectives, you can compute like these two by itself. You don't need labels for that. Okay, so you directly learn from data itself.